So like I said, this is page 6 of your notes and the answer key. I'm just recording that. You're welcome to take your time with it and fast forward and rewind. But it does show that some of these are one step and some of them are two steps. You really do use dimensional analysis to kind of make those conversions. And so the first four are one-step problems, kind of just moving from one box to the other and using the appropriate unit factor. And then the ones at the bottom here, the last two, are using two-step problems. And so really navigating from one box to another with different unit factors. And I like seeing it as a bit of a roadmap to that. The most part of this video is going to, oh, and you do have the answers at the bottom there. Most of this video is on percent composition. And so back to your notes, as we fill out percent composition, this is going to go back to this idea of the fixed ratio of different elements in a compound and their molar mass, and how that compares to the total molar mass of the compound. And so percent composition by mass is what it's sometimes talked about. And so really, if we want to figure this out, we need the molar mass of the compound. And then we're going to take each component, each element as a component of that compound to figure out what percentage of its mass is made up of that specific element. So one of these is maybe better to show me, don't tell me. So if we take a look at this one, we're going to figure out the percent composition of the elements in sodium phosphate. And so I always kind of do it in this way. So I'm going to deal with sodium, and I'm going to deal with phosphorus, and I'm going to deal with oxygen. Those are the three different elements in this compound. So this tells me, much like I figure out my molar mass, I've got 3 parts of sodium with a molar mass of 22.99 for 68.97 grams per mole, if you will. And phosphorus, there's 1 part phosphorus at 30.97, so that's just 30.97 grams per mole. And I like doing it like this because it kind of mirrors what you've already done. And I think that that's handy for kind of building more knowledge and understanding. So the molar mass component that is oxygen is 64.00 grams per mole. So if I want to figure out the percent of this that is sodium, I would take this number, which is all sodium, and divide it by the total molar mass. So the molar mass of the entire compound like you've been doing before, if I added these all together, I'd say that it's 163.94 grams per mole. So the percentage of this element, or this compound that is the element sodium, is like 68.97 out of a total 163.94, always with a percentage. And I said, like, it's like you get the that many right on a test, right? The percentage would be this. We're going to, just to be consistent, round to 1 decimal place. That's a fairly arbitrary statement here that seems to make things work out. I don't think I'd dock you marks if you did it differently, but yeah, so we end up with 42.1% of the compound's mass is made up of sodium. The percent by mass that is phosphorus would be that 30.97 divided by the total molar mass and times 100 to figure out its percentage. And so the percentage of this compound that is phosphorus is 18.9%. And similarly, I like these because they're very repetitive and they're much like figuring out molar mass. The percent that is oxygen would be the 64.00 in a total of 163.94 grams per mole. And so again with this one, rounding to 1 decimal place, not really worrying about sig figs, 39.0. And so that's how we figure out the mass, the percent composition, or the percent composition by mass in these. So this one says the percent by mass of tin 4 chloride. And so in this one, I like doing it like this. So tin and chlorine, and I know that I have 1 part tin, and tin has a molar mass of 118.7. So this fixed ratio idea we're developing even further. We've got 4 parts of chlorine, each one at 35.45 grams per mole, so a total of 141.8 grams per mole. If I was doing the molar mass of the compound, that's a total of 260.5 grams per mole. And these numbers now set me up to do the percent of tin, which is that 118.7, or 118.7, yeah, sorry, out of a total of 260.5 times 100, and that's the percentage of this compound that is tin by mass, so 45.6%. And then the percent that is chlorine is 141.8 out of a total of 260.5 times 100 for a percentage of 54.4%. So as a skill, I like this one. It's a nice, neat, tidy one. We're going to use this as we continue and understand how we could derive mathematically and experimentally the actual compounds of formulas.